Hello friends, सबको namaste. So today in this video we will create a vehicle speed estimation code. Okay, so this is a preview of the code. Let me show you one. This is the as soon as line B cross this truck crossed this speed will be there, and this speed is here. Let me come to this car. Wait for it. Before explanation of the code, please like, share, and subscribe my channel to make more videos like that where I will explain you each line. Okay, as soon as it cross line B, it is speed will be there in place of ID. See, 34.5 kilometer per hour. So let's get started. Let me close it now. Okay, so this is just extra line which I have created just for the getting the fun frame for explanation purpose, like this one. Okay, for explanation purpose I want this thing. Okay, so let's get started. You can see that these are the steps which we want to follow, but I will just directly start for you. These are the package which we required for doing for creating this code. Then this is video path, and this is okay, you can see this is let me close it now. Okay, save it. Yes, see, this is line first line and second line coordinates values. You can see it. This is line one. This is x1 y1. This is x2 y2, and for line B x1 y1 and x2 y2. I have calculated those values using a paint software. Okay, so it's up to you how you can do that. Now this is real distance. Means when you will run this code, you in okay, when your camera is static at a certain position on a road, and you want to calculate the speed of the vehicle when it crosses it, so you have to when you draw this lines, you have to first calculate manually. You have to calculate that what is the distance between those two lines. Okay, whether it's 8 meter, whether it is 10 meter, or whether it's 20 meter, it's up to you. What you have to calculate manually, you have to calculate the distance between line A and line B on a road when you put your camera on a static in and on a road. Okay, so this is what it is, and I assume it's 8 meter. Then what is the meaning of margin? So what is the use of margin here? That suppose whenever when a vehicle cross or near to cross a line A, I will make a certain range. That pick certain range when I will we can say subtract minus I will what I 8. So 8 will be margin. I will subtract by from y1. I will subtract 8 pixel and add 8 pixels. So I will make one margin range here, and when the vehicle y certain y value vehicle center y value come in this range, we can say that per particular vehicle crosses the line A, and same way for the line B. You will get if you get confused, I have a calculation for it. So this is a calculation, but I will come it here later. Okay, so I have given you a short explanation for this. So this is the color which I have set: line color, box color, text color, and the center color. Now this is a model which we are using YOLO11X, and these are the you can say video we recap for the video capture. This is FPS, and this is delay. Okay, how much delay per second I want for this is that's why I calculated it, delay. Then frame ID will be initially it will be 0. Then I am making a dictionary. I am making a dictionary? Because I want to store, see, track ID, and inside a track ID this is A frame number and B frame number and speed. A frame number means when a you can say when a vehicle cross line A, at that particular time frame number will be stored, and when it cross line B, frame number will be stored. Why we are storing frame number? Because using the frame number we easily get the time, the particular time, that how much time it takes for the vehicle to cross that 8 meter. Okay, and after that we calculate the speed. So this way we capture all value for the particular track ID in this dictionary cross time. Okay, then I want to extract y1 coordinates of line 1 and y2 coordinates for the line 2. So this will be extracted. Why we are extracting this? Because we want to make the range, but which I had explained you after -1 -8 and +8 from this y1, and -8 +8 for line 2, line B y1 y2 y1 value. So this is the way, and you can say y1 and y2 value for both first line second line is same: 324, 324, 381, 381. Okay, now we have to loop over the video. So how we can do that? For that we use a while true. It will read the frame frame by one. Then it give me two values, rat and result and frame will be the video frame, and the result will be, it can be true or false value. If the frame is there, it will be true, otherwise it will be false. Then I will iterate, means I will update the frame id as soon as the frame is been read it. After that, this is the main thing, tracking uh, is happening with the help of the YOLO. How we can do that? Just a model dot track you have to use, then you have to pass the frame. And what is the use of persist true? Persist true, you can say keep object ID consistent across frame, so the same vehicle keep the same ID while moving. So this that's why we use persist true. Then verbose true. Why? Verbose true disable console log for every frame, means keep terminal clean and faster. So this why verbose will be false. And this way, how and as so you know, we are just passing the single frame, or you can say single image. So to get the result of the single image, just use zero index value, we'll get the result. After that, we put that line, we draw the line on the frame. How? We just use frame line 0 initial position, and last end position, start position and an end position, and just line color which we have selected, and this thickness. And same way for the line 2, just to frame, then the second line start position, end position, and the color which I've selected, that thickness. Then how we put the text? Just use line A, then a first line x coordinate value and a y coordinate value minus 12. This will display the text above the line A. And same way for the line 2, we put the text. Now after that, we want to iterate over the result which we get, that how much the detection is performing. So for we if the result of box is not none, it means though if there is any detection, then only you have to move under the if statement, otherwise you do not move it. So for that purpose, we just iterate over the result of boxes, and it will give me in one single frame how many detection are performed, and how many detection perform. Each bounding box has its unique id and coordinates values, and also the class id. So you can see that filter vehicle classes means the box or class 0, it give me the class id. And if a class id is under this 2 3 5 7, then only it's move down, otherwise it will skip this for loop, because we don't want to predict, or you can detect other thing. We just want to detect car, motorcycle, bus, and truck, and those class ids are 5732. Okay, so that's why if class id not in this, it will continue, it will skip the for loop. And after that, we want to expand the bounding box detail, or we want a bounding box details. So how we can do that? Box dot expect 0, give me the bounding box detail. And what is the use of int here? Int means it might most of the time the bounding box values are not in a int format, they are in a float value. So that's why we have to convert it into int, and it's those value will map with this x1 y2, x1 y1, and x2 y2. This way we get it. After that, we want what is this? This is tracking id. If box dot id is none, we continue it, otherwise we will get a track id. How we get a track id? Just use box dot id 0, we get a track id, and we convert that id into int format. Okay, then what we want, the cx and cy. You can see, suppose I draw the bounding box, suppose I draw the bounding box around this car, and I want the center position. This bounding box, I want a center position. So how we can calculate this? So this is the bounding box center position, x plus x1 plus x2 divided by 2, give me the cx, and cy is calculated this way. Okay, because using the center position of the bounding box only, we calculate how what is the speed of the vehicle, and at which time the particular vehicle crossed line A and line V. Now what is this initialized track entry? We have to update this cross time, can say this cross time dictionary which we have created. How we can do that? We are updating it now. See, if track id is not in cross time, if not in cross time means if it is already in the cross time, it's not required to update those values again and again. We just want to update the value one time only. If so, that's why if cross time track id, it means we passing a will be no, means this time this particular track id has not passed the line a, and same for the b, and speed is also none. Initially it will be none. Now what is this thing? Now you can see what is this? If cross time track id a is none, if particular id track id a is none, it means it does not pass the line a, then we will do some calculation. So this is a calculation which I had explained about, that how we use the margin. So let me explain you one again. Suppose line y1 value is 300, position of line a. Okay, line, let's assume. So okay, so don't confuse that. Here it's line 1, y1 value is 324, but here is 300. I just kept just for the explanation person, so don't get confused. Margin will be 8, and after that lower bound, I have created one range here. So how I have created line y1 minus margin, margin means 300 minus 8, 298. Upper bound will be minus 308. So this way I created the range. When if this bounding box cy, if bounding box cy is under this range, we can say that particular vehicle has crossed the line a. So solid crossing range between 298 to 308. So if it is a cy is under this range, we can say that it's crossed the line a, and we update the cross time track id. A will be frame id. Okay, now same way for the same way when it crosses a line b, how we can know that? Just see that we get some condition here. If line track cross id track id a is not none, because then only we can say it crosses the line b. So and also cross time track id b is also none, then only we can say that he had that particular vehicle had crossed the line a but not crossed the line b. So now we have to do the cross calculation for the you can say, let me cross it. Okay. Okay, then only we can say that it for the line b we have to do some calculations. So this same way this we have to make the range, and we can see if it is under the range, we can say it's cross the line b, and after we get the frame id. So what is happening here? This whole calculation I have explained using this. See, let me make it more clear. Real distance in 8 meter we have selected, frame fps is 30 seconds. Okay, vehicle cross line a at frame 120 and cross line b at frame 180, let's assume. Okay, and 180, let's I have explained. Let's see, that's after getting the, it's we can conclude that it's cross the line b, so we have to get a frame id, means that particular frame id. Then we put f1 f2 cross id. Okay, we get it. Now we have done some calculation here, so that calculation I am explaining here. Okay, after getting this frame, f1 will be 120 and f2 will be 180. Step 2, calculate number of frame taken. How much frame will take to cross that particular line a to line b? How much frame? 60 frame it's take. Now compare frame to time. How we can get a time as? Time ms will be frame taken divided by fps. So time will be 60 divided by 30. 2 seconds is take to cross line a to line b. Okay, now after that, speed in meter per seconds. Speed in meter per seconds will be real distance divided by time. You will get a speed, because we have you can say we have calculated that so that we have assumed that real distance will be 8 meter. So that's why we get the speed in meter per second. So we have to convert that in meter per second for kilometer per hour. So we have to multiply it with 3.6. So after that we get a kilometer per hour second. So same thing which we are doing here. Time, after getting time, we convert if time is greater than 0, then only we get the speed. After getting the speed, we multiplying with 3.6, because we want a speed in a kilometer per hour, and we just updating the cross time track id. Speed will be speed. This way we get the speed of particular track id or particular vehicle. After that, we draw the rectangle around that vehicle, and also we draw the say circle. Also you can say the center point, and also we put the label. Initially the label will be track id. Initially the label will be track id. As soon as the speed is not none, we can say it's crossed the line, and we have also get the speed variable. So speed not in a dictionary, we get a speed value. So we have this. Now the label will get changed, and then label will display here. So this way we are doing a put test and circle, and after that we just show the frame, and this way we are calculating the vehicle speed using YOLO tracking, also YOLO model and YOLO tracking. So this is a very simple code which I've explained you line by line and how the calculation is performing. So let's get started. Let's preview the code. Let's run this. Wait for the seconds. This will take time. Okay. My GPU is not that much fast, so wait for the seconds. Okay. Initially, it was not detected, so this vehicle track ID is not detected in line A, so that's why it's not getting any speed. But right now, this two vehicle will get a speed 43.2 and 43.2, same speed. Now back one, this is 46.0. This car is 69.1. This is, see, as soon as its center passes line B, its speed will display. See, 40.6, 40.6, same speed. Let's come for this car. And one more thing, I have already tell you that the distance between this line A and line B, you have to calculate manually. Okay, it's I have just assumed that its distance is 8 meter, but you have to calculate manually if you are using this code in real time or in real world. Okay, 34.5. Okay, so this way it's working. So I have explained this whole code line by line, an easy way how easily you can easily calculate the speed of the vehicle. If you get some knowledge with my video, so please like, share and subscribe my channel. Thanks to all.